Good. So as we have today the second part of the NPV and cash flows class, let's first revise what we learned last time. Could some of you please remind just the titles of the main things we discussed last time? Do you remember any terms we discussed? You can either speak or write in the chat something that you remember from the previous class and also from the seminars. What terms we used? Interest rate. Yes, Elizabeth, this is good. We discussed that there are two types of interest rate. What were those? And maybe the difference between them? Simple and compound interest rate. Yes, yes. The simple is the one that that assumes that there is no accumulation of wealth, and in compound interest we work with accumulation of wealth, and the compound is the one we mostly work with in our financial estimations. Future value, present value. And what is that, Uliana, or maybe your group mates? Could you help us remind what we mean by future value, present value, why we need this? Today we will continue with that. This is very useful concept. Future value. Present PV value today or future cash flow. Yes, yes. Maybe could you? There was one concept of the what we should consider in order to compare money in different time period. There was some value of something. Do you remember that term? This is the term due to the one we need to work with the present value and the future value concept. We talked that money.
You mean?
Mm-hmm. Please go ahead if someone wants to.
Do you mean the discount rates that we applied? The future value to get the present value?
Yes, yes. And there is this general idea, no, I mean it's time value of money concept. Due to that, we should compare not money directly. So if we receive money that are distributed over time, it is more accurate, instead of comparing them nominally, to compare their discounted values or compounded, depending on where we go in the timeline, backwards or forwards. Compound and simple. Internal rate of return. Yeah, and internal rate of return and NPV. Can someone connect those two terms? Internal rate of return, NPV.
May I answer that?
Yes, please go ahead.
Oh, okay. So so internal rate of return on, or IRR, is the that point in NPV where. Sorry.
Alexandra, I hear Averyanova Alexandra.
Oh, I'm sorry.
Here you're talking cell phone during the class.
Oh, sorry, I thought she was talking. Okay. Yeah, so IRR is that point in NPV where we are not receiving any kind of we are not receiving an interest due to the fact that the money will lose its value over time in the future. So the NPV is approximately 0. So
internal rate
connection you were
of
looking
return. Yeah, internal rate is the return of the discount rate, which makes NPV 0. Yes, so this is what you
Exactly.
said. Yeah, this is correct, and this is internal rate of return is one of the ways we can use single estimation of the project performance and the project effectiveness. We will soon discuss another alternative, but no, they are anyway very well aligned. And NPV is the estimation of project effectiveness. The higher NPV, the better, but the threshold is 0. If it is above 0, it means that this project exceeds the opportunity cost of capital, so the project is better than alternative ones. And it means that we should accept it. Today, by the way, we will consider how to work when we have a set of projects and some budget constraint, and how to incorporate this all together in order to make the decision about allocation of investment projects within the firm. And in the last part of the previous lecture, we considered another estimation of the project effectiveness, which is estimated in the time units. Could you please remind us that? Oh, you can write payback period. Yes, Uliana, payback period. Thank you. This is the one we were talking about. And this one estimates the time the project needs to break even. In other words, how much it takes, then all our investment that we made will be compensated with incoming cash flows. It can be either nominal or discounted payback periods, depending on which types of cash flows we use. If we have both, it's better to work with a discounted payback period, because then we consider the time value of money. That makes our estimation more accurate. So we considered some ways we can estimate investment project where it's worth implementing or not. It was NPV, internal rate of return, payback period, and today we consider some. No, first of all, we will talk about the way we put multiple projects in the portfolio of projects, considering money constraint. Then we consider another very important topic in terms of the time value of money, in terms of the present value estimation, is the topic how we convert shorter term interest rates to longer term interest rates. I believe you could have seen different offers like interest rate per day, interest rate per month, but the default one, as I told you last time, is interest rate per year. And we should keep in mind that it is always good to compare any interest rate we were offered to the annual one, and then make a decision, because judging by the daily interest rate might be very misleading. Then we will consider two related topics, but those are very important topics in terms of the banking activities, in terms of the loans, credits. Those are perpetuities and annuities. Those two are the special types of the cash flows. Perpetuities is an infinite cash flow, and annuity is a set of cash flows which is restricted in times, and both of them are the equal amounts. So we either receive or pay equal amounts with the same time intervals, either forever or for the limited time period. And as you might expect, this is type of cash flows we use when we borrow money. So there are an annuities payment when we borrow money for the bank. These days almost everywhere we pay money back using the annuities, and we will consider some practical examples how those annuity payments can be estimated. Okay, let's start. When we consider the projects, we usually act from the perspective of the bigger firm. And bigger firm has multiple options where this firm can invest in. And anyway, even when the firm is huge, there would be some budget constraints. And depending on that, we use the term in order to name the concept of limited resources that the firm has. It's called capital rationing. It's a limit on the amount of funds available for investment for the investor or for the company or for whoever conducts those investments. It can be either soft rationing, then this limit is imposed by the management. So firm decided that it would allocate only this amount for investment. Alternatively, it can be just due to the lack of resources. Then there is just no any other available resources. So in terms of the soft rationing, in case you find some perfect, bright investment opportunity, you might persuade your management that it's worth implementing, and they might agree to allocate more resources. In case of hard rationing, there is no other resources available, and so this constraint is stronger one. And the settings that we consider here is that we have some money to invest and we have multiple investment projects to compare them, or also we can implement multiple projects if we fit into our budget constraint. And in order to compare them, we need to use some estimations. It's better than this estimation is a single one. We talked that there is an internal rate of return estimation that we discussed last time. And there is alternative estimation that you might frequently see in the investment projects. It's called the profitability index estimation. And now we are about to discuss how it works. Now we have a chance to revise the concept of the net present value here. We can consider the first projects in order to revise how this NPV works. So NPV, let's write it down. NPV of project A. First, let's estimate this. We have investment of minus 120. Then in the first period, we receive 50 units of currency. How we would include it into the cash flows? Could someone remind us what we should write? We see that the discount rate is 10%. How we should write the rest of the NPV here?
If I'm not mistaken, it's 50 divided by the 1 plus 0.1. And since it's the first period, it's in the power 1.
Yes, Irina, well done. So this is 50 divided on 1 plus 0.1. So this is the same 10% that we use as discount rate. And what we will do with the second cash flow, how we include this one. I might try to ask some of you just directly. Let's say Larionova Irina. Do you know how we can include this second cash flow? Irina.
No, I don't remember. I'm here. I'm listening.
You listen. Okay, so no, this should be the first time you hear it. No, let's hope this time you will remember. Arina?
So, okay. If somebody wants, please.
I can say. Can I? Yes. Okay.
Yes,
we
yes.
need to divide 105 by 1 plus 0.1 in power of 2.
Yes. Very good, Elizabeth. Thank you for your help. This is what we start. So 1.1. This is the same thing we had in denominator of the previous cash flow, and we put it in a power of 2. This is it. Then we would have NPV of 12.23. We would have NPV like that, and we replicate it for each of the for each of the project A, B, C, and D. And then we can introduce the single estimation of the project profitability. Some people work with internal rate of return, but frequently you will see this profitability index in some presentation materials regarding the investment, and that is why we should be familiar with both of them. But obviously, the higher internal rate of return, the higher profitability index would be. So they are very well aligned. There is here you see two alternatives how we can estimate. For NPV is the one where we consider investment, and present value in this case is the one where we have only incoming cash flows. Sometime in practice, people call present value of all cash flows, including investment, so you shouldn't focus on this term. We wouldn't say that present value is the one where we do not include investment, and NPV is the one where we would include investment, because it might be misleading when you will start working with other materials. But in this case, we cannot say NPV if there is no investment included, but we can say PV if there is investment included or not included. In this case, we have two alternatives.
Can I have a question? And how in this case we will count PV? By which formula? Can you remind, please?
No, PV is just the more general term. NPV is one particular type of PV, of present value. So present value, it can be.
So here. So here we just plus our investments plus our NPV and have our PV. Yes.
Investment plus. No, subtract. We subtract.
Yeah, because investments are, yes, of course, negative.
Yes, so we subtract NPV from PV. No, look here. It is relevant for the first three cases. So we subtract 120 from 132, and this is what we would have. Because they're not discounted.
No. I have a question about PV, how we can count it only with using NPV, but can we count it without using NPV here by another formula?
Yeah, sure. This is all incoming cash flows we have. So if we would keep only second part, so only something we receive without something we paid.
Okay, understood. Thank you very much.
This is only incoming profit, this part. This would be PV. But again, I don't want you to remember that PV is always without investment, because in practice, people sometimes confuse this term. Just remember that in different cases, you might see the different things. In our grading part and wherever we will be precise in terms of the thing we want you to calculate, and there won't be any ambiguity here. The case that we should consider here, that investment, the project D, investment sometimes might be spread over time. And if we make investment not in period 0, but in period 1, we would discount it as well. So here would be everything the same, just we would minus 40, we will divide on 1.1. And the rest would be the same. Then we, after we estimated NPV or PV and investment for the case D would be minus 40 divided on 1.1. So this is a little bit less. The concept here would be the same. If we need to spend some money 1 year later, it means that we can at least put those money in the bank, and by the end of the year have more money available. That is why when we estimate their present value, we discount them as well. And how we estimate profitability index, we either divide all present value of all cash flows that we received on the present value of all cash flows that we pay. Alternatively, if in NPV we included both incoming and outflow of the cash flows, we would divide NPV by investment and we would add 1. And this would be the profitability index that we use in order to estimate the performance of the project. Then we have multiple profitability indexes in place, and the higher profitability index, the higher would be return on the investment we made. And the next step, considering that we are in the situation of the capital rationing, meaning that we have a limit on the available cash flows, we make a decision how to allocate our money among the projects that we have. And let's consider these alternatives. Here we have different set of projects. Here it is. So we have profitability index for each project, and we have amount of investment we should make in order to fulfill this project. In total, we have 300, and there are multiple combinations we might consider, but the point is that we want to have weighted average profitability index, the highest one. Let's consider some case. The first alternative that we consider would be invest everything in the project A. Then how we estimate it, this is weighted average profitability index. We multiply its profitability index on the investment that we should make here, divided on the total limit we have. Here it is. That is why this is weighted. It is weighted by the investments we make among those projects. It is weighted by the investment. And here, what we should keep in mind is if we invest only in project A, we have 100,000 that we haven't used. This is left. Therefore, the profitability index on the money that we do not use is 0. That is why we should include this part in this equation. And weighted average profitability index for the project A is 0.77. Another option we have is to combine together two projects, project B and project C. The logic is the same. We multiply profitability index of the individual project on the investment that we make in this project and divide on the total limit of the money available. And we do it for both of those projects. And this is how we get this result. And seems like this is the outcome that is the optimal one, as we have the profitability index highest.
Can you explain, please, what is limit? What does it mean?
Yes, Uliana. I started from it, but no, let's maybe look at this from another perspective. This is the all money that we can invest. It can be the firm or it can be your personal financing. So let's say you have a salary of 100,000 rubles and you want to allocate this all for purchasing some stocks. And then this is the limit. This is the maximum amount that you can spend. Does it make sense to you, Uliana?
Yes, thanks.
Sorry, can I ask a question too?
Yes, sure.
It's about the previous slide. So the investment will be, for example, in D, it will be -40, right? So we should divide NPV by -40.
No, -40 divided on 1.1 because we invest them 1 year later.
Oh no, like in the formula when we already counted the NPV and then we count the PI. So it's written that, for example, we need to divide PV by investment. So in project D, our investments in -40.
No, -40 discounted.
Okay, but and in the previous project like ABC, it's as usual -120.
Yes.
Okay.
I believe in the seminars you will have a special example dedicated to it, and you will have a chance to calculate it yourself. And once you do it yourself, it would make a good sense to you.
Okay, thank you.
You're welcome. No, as we discount incoming cash flows, we also discount investment that we make, because anyway, if we have to make some payments later, it's easier because we have some time to find the money. Or if we already have money in place, we can make additional money on them and make payment later.
Sorry, but how the API for B and D project calculated? Because no.
In this slide or in previous?
No. Then other question: how we can calculate the API if for two projects if the sum of investments in table are bigger than limit?
No, in these conditions, we just cannot consider this combination because we exceed the limit.
Okay.
Yeah, Uliana. So we consider only combinations that fit the limit that we have.
I've understood.
No, this is the idea of this constraint. Otherwise, we would just accept everything and make more money. Good. Then, no, by the way, further in our class, we will consider the ways what we can do when we exceed our budget constraint, but it would be in the subsequent classes. Then we will talk about efficiency and portfolio allocation. This part, there is a way, but so far, just to understand this concept that there is no, as we talk, that investment is the main activity of the firm, and we try to make it more practical at this time and show you that there are some restrictions on the amount of money that the firm can invest. And these examples are there to show how these restrictions work. And even though, Uliana, I see you had a good point. So if we would, for example, compare project A and B, as both of them have higher profitability index, you might plan that it is good option that in this case we would have highest weighted average profitability index. But as in this example will exceed the limit, it means that we cannot consider this combination of projects. Good. Now let's move on to the issue of converting interest rate from shorter periods to longer period. This is a very important issue, very important, practically important, and for surely important from the perspective of the firm. As you might be offered to paying some amount of money per month, per day, and they show you interest, and this is obviously very low, and you think that this is a good offer. But in reality, if we compare it with alternative offers, you will see that interest you have to pay is a huge one. This is a trick which is very widely applied by the microfinancing organizations. They tell you on this loan, you pay only 1% per day. This is so cheap. But in reality, this is not cheap at all. And we use several terms here. Annual percentage rate, interest rate. This is annualized using simple interest rate, and effective annual interest rate, which is annualized using compound interest rate. This is how it works. Let's say we have an annual rate and we want to convert it to the monthly rate. This is what we do. If we have a simple interest rate, we would just divide it on the number of periods. Let's say from year to months, what would be the M in this case?
12.
12, Farina, great. And if it would be quarters, from year to quarters. Let me ask someone. I want
4 probably.
4. Good. Yes, so this is easy. If it would be days, it would be 365, or sometimes when we consider only working days, it would be something around 200. And no, this is simple thing. If we consider compound interest, which is mostly the case, then we use slightly different formula, but no, still not that difficult to compute. This is it. So this is 1 plus annual rate in the power of 1 divided by the M, where M is a number of smaller periods within the year. This is it. So we barely use the periods that exceeds the year. Usually the conversion is either from annual term to shorter term, quarter, month, day, or vice versa, from day, quarter, or month to the annual term. And this is the case where we go from annual to the shorter term. Alternatively, this is the opposite operations. You see, if we were offered information about monthly period and we want to estimate it in an annual period, we use this formula. Quite simple. Just make sure you understand whether it is a compound rate or simple interest rate. Mostly we will work with the compound interest rate. When we talk about the borrowing money, it is usually the case, but no, we will have an example where we will compare the outcome of those two. Let's consider the example. We have an offer of the monthly rate of 1%. What is effective annual rate? What is the annual percentage rate? Could you tell?
12?
12 is the which one? APR?
APR, yeah, for APR is 12.
Yes, Arina, well done. This would be 12. And for effective annual rate? How we would approach it, maybe. You don't need to tell the number exactly.
We need to add 0.1 to 1, and that sum we should power in the power 1 divided by 12.
So,
Vice versa. Almost.
So it may be 13.12, if I'm not mistaken.
13.12.
No? Maybe
If we go from monthly period to annual period, the result should increase. So this is, I think, Georgi, what you said were a little bit different. You use the formula of the opposite case. Just use the logic. So if we go from month to a year, this rate should increase. Elizabeth wrote, yes, Elizabeth wrote correctly.
Okay, I got it.
No, this is, if you just, just read the question carefully, and also you should keep in mind like 1% per year. Usually, it can be, but it is usually smaller one. If understand the levels of the interest rate. If you make some computations and you see that the annual rate is very, very small, double check the exercise itself, because you might have been confusing something. But also it can happen in real life that the annual rate is actually small. For example, when the stock price is very volatile, and when we take two points in time, the difference between them can be not that big, even though during the period the stock price moved stronger. Yeah, and this is important. I highly recommend you, then you deal with any other interest rate, not annual one, but shorter one. Always compare them with the annual term. Convert them using effective annual rate and compare them with the annual terms that you might have. then you would avoid the confusion. Now we move further. Now, does it make sense to you, the thing we just discussed? Is it clear to those of you who followed?
Yes.
Yes, it was.
Yes, thank you, Arina, Georgi. Very nice to hear you. Yes, Anastasia also, thank you for the feedback. Now we move further. Those topics are related, but no, still they are distinct but interconnected. Now we're approaching, I think this is the most interesting part of the today's class, is the special types of cash flows. We will talk about perpetuities and annuities. Why I think them interesting? Because they are very useful in practice. I personally use them when I used to work in a bank, and now when I, for example, want to purchase something and I need a loan for this. Let's say you want to purchase a flat or you want to purchase a car. Yeah, I wouldn't recommend you to take a loan for some smaller payments, but it can be the case. And this is very important to understand the financial math here. Fortunately, this is a very simple one, and this will help you to avoid misguidance that you might have from the salespeople. Let's go step by step. There is a concept of the same cash flows which are paid forever with a fixed time interval. It can be, let's say, every year at the 31st of December, you receive 1 million rubles forever. Once after you, your children will receive it, and it can be infinite. In history, in France, there were such type of securities. I believe they were called console securities. So state issued such security. Once you purchase it, you are eligible to receive the same amount of money regularly forever. I believe after 200 or 300 years in 20th century, they finalized them. They terminated, but there were such cases. And also why this concept of perpetuity is important, because maybe some of you remember from the first lecture, we discussed that we have assumption of eternity when we talk about firms. That firm has no expiration date. Firm operates, and we do not expect it to end its operation. It means that we expect it to operate forever. And that is why many estimations regarding the cash flows that firm generates, they are based on the perpetuities. Perpetuity includes the concept of compounding, not compounding, but discounting. And the further we go, the lower would be the present value of those cash flows, and ultimately the difference, if the discount rate is not very small, that the difference between the set of cash flows we receive for, let's say, 30 years and the set of cash flows we receive forever, the difference between those two won't be big, because if we talk about the very distant cash flows, they are discounted stronger and their present value is getting lower and lower, and they are not very important for the present value calculation. But still, this is the concept that we would use, and this is important from the theoretical perspective, and this is also important as this is the one we use for estimating another type of cash flows. This is perpetuity. Again, this is same cash flows received with the same time intervals forever. This is called the perpetuity. Another important thing to mention here is that when we talk about the perpetuity, first cash flows is paid at the end of the period. Not immediately, but at the end of the period. So the first cash flow is would be already discounted by the power of 1. Usually we talk about the years. By default we talk about the years, but it can be any time period, month, day, wherever. Just make sure the discount rate you use is appropriate one. If we receive money every month, discount rate should be monthly, and so on. Unfortunately, the formula for perpetuity is very, very simple one. This is the cash flow divided on the interest rate. Very simple to estimate. Let's consider the example. Present value of 1 billion every year. The first payment is at the end of the year 1 for the eternity. At the discount rate of 10%. Here it is, 1 billion divided on 0.1, and the result is 10 billion. I hope it makes sense. In the course book, the Braley-Myers, there is it's written how we derive this formula. I wouldn't spend time today to show it to you because it's we can omit this, but there is a simple mathematical procedure to confirm that present value of perpetuity is really derived with this simple formula. Another thing that we might think about is the present value of perpetuity that starts not at the end of the first period, but the one that starts later. Here is an example. What if the investment? No, excuse me. What if the investment does not start making money for the first 4 years? The first payment is made at the end of the year 4, and this is the formula. Please beware again. If the perpetuity formula is this one, then the first payment is made at the end of the year 1. In order to estimate what would be the present value of the cash flows, then the first payment is made at the end of the year 3, or actually year 4. We put we use this such discount factor. So the first payment is at the end of the year 4, but the discount factor is at the power of 3, because this formula itself is already making the step for the first year. This is why here we have only 3 for the case then the first payment is made at the end of the year 4. And here it is. And out of those two simple things, we can derive the present value of the set of cash flows for the 3 years. This is this example, 1 billion every year for 3 years. Does it make sense to you? So this is the one when we have it forever. This is the one when we have first payment at the end of the year 4. And this one minus this one, what it would give us?
Payments in these first 4 years?
first 3 years. But good start. Yeah, this is the present value of the free equal cash flows for 3 years. And this is exactly the settings that we use in the banking, in the borrowing money. This is the annuity term of borrowing the money. On this slide, I present the same concept in a general term. Let's look at this again. Perpetuity, the same amount of money at this fixed time interval forever. Here it is. Perpetuity, postponed perpetuity, then the first payment is made at the year t+1. Here it is. And if we receive payments only for the first t years, this would be this one minus this one. And this is, I think we have here, is called the perpetuity, annuity factor. It's called the present value of annuity factor. This is the same thing as here, as here. We would just take the C out of brackets. C stands for the cash flows. Here it is. This is the present value of annuity factor. This is the perpetuity factor, and this is the factor for postponed perpetuity. And this is how you remember this formula. This is one of the most complicated formula in our course, so we will not have very complicated formula, but you can, I believe you can remember it just following this logic. This is the formula for perpetuity. This is the formula for postponed perpetuity, and the difference between them is the formula for annuity. And annuity is the cash flows which are very widely applied, and we will discuss some applications soon. Let's consider the example. Some auto retailer offers you the installment plan of paying 5,000 per year at the end of each year for 5 years. Interest rate is 7% per year. And you should estimate the cost of the car. What would be the price of the car according to this estimation? So this is the price of the car, and this is present value of annuity factor. This is how much money you would pay. And this is estimation. This is the first payment. We divide at 1.7, and we divide each payment accordingly, and we have the same result. How this can work, how this usually works. We usually have in the shop, we have some price. This price can be given. This is a price offered. And based on the interest rate and the number of period and the frequency of payment, because usually it's not annual payment, it's usually monthly payment. So we would need to make adjustment in interest rate and in the number of periods. We divide the price on the present value of annuity factor, and we would have the annuity payment that we should make. Let's consider this example. What is the This is the similar settings. We have a we have some price received, so we are offered some price, and this lottery, they suggest that instead of paying the money in a full amount, they would divide it in 30 parts and pay each part separately for 30 years. And if we apply the formula of the annuity here, the true value of this option would be 357.5 instead of 590. You see that the difference is quite huge, and that is again the idea of the present value of the money, that instead of receiving all the money now, we receive it for the 30 years, the same nominal amount, and that is why the true value of this option is lower, is getting lower. This is another setting. This is the settings you would see in the shop most of the time. You want to purchase something, and the shop offers you to make the payment in four parts at the 10% rate. This is how much you would need to pay 4 times. So you see, if we multiply 315.47 at 4, it would be more than 1,000. Because here we also use the interest rate, and this is this annuity system. This is the real tool that you would that would be used. Then you make some purchase, make some payment. This is the example I prepared for you. I would open now the Excel spreadsheet where we have it. Where is that? Where is that? Where is that? Yeah, here it is. I would share this file with you. And by the way, you can use it not only for the course, you can use it just for other settings. Then there is this online calculators of the payments, of the annuity payments, but you can do it yourself in Excel to understand the mechanics better. And here it is. We want to borrow 800,000 for 5 years with an annual interest rate of 11.5. Let's estimate how much money we would need to pay every month and how much we would overpay. What is the sequence of action? The first thing we start from, we should estimate the interest rate for the month. This is the annual rate. We convert it to the monthly one. Depending on the procedure we use, either compound interest rate or simple interest rate, we have slightly different result. And with this interest rate, we estimate the number of periods. There is 5 years, but payment is monthly, so the number of periods is 16. Number of years multiplied and the number of months per year. Then we estimate the annuity factor. We use the formula that you just saw on the slides, and here it is. And with this annuity formula, finally, we just divide the total amount by the annuity factor in order to estimate monthly payment. There are two alternative amounts, and in the loan agreement, it's not fixed how it's calculated. Bank can do in its own fashion, but you see that for the bank, it is more lucrative to use the simple interest rate, because the monthly payment would be higher, even though all the other conditions remain the same. Just the procedure of converting interest rate from yearly to monthly makes the payment higher. And this is the table. How we proceeded. Let's look at this. We took the loan. We took 800,000 from the bank. This is the amount of money that we owe to the bank. We just estimated that every month we would pay this amount, and you see that this amount is always equal. And paying that, our payment goes to the two parts. One part is the money we pay for using the loan, the money that we pay to cover the interest. How to estimate it? We multiply the residual amount of money that we have on the interest rate on the relevant interest rate. Yeah. So we pay this, and this part goes to cover the interest payment. The rest of the money is here. It's called amortization of the loan. And amortization of the loan is the part that reduces the residual amount that we owe to the bank. So by the end of the month, our result is the result of the beginning of the month minus amortization of the loan. And the beginning of the month is the same as the end of the previous month. This month, we go through the same procedure that annuity is the same, but as we have this amount is getting smaller, you see that the interest, the payment to cover the interest is getting smaller as well. It's smaller this time because this is calculated out of this amount. So amortization of the loan is bigger because these two sum of those two values, amortization of the loan and payment on the interest, they together, their sum should make up the annuity payment. So amortization of the loan is getting higher, and end of the balance. So we put more money to service the debt, and over time, the fraction of the amortization of the loan is increasing, and the payment to cover the interest is decreasing. That is why it is better to pay the money the earlier the possible. If you if you have some extra money to cover the debt, it's better to pay it earlier. Then you save the most on the interest payment.
Can I ask a question?
Yes, Uliana.
What does the percentage on the last column mean?
Percentage? This one?
Yes.
This is a fraction of the money we pay to cover the interest in the total value of annuity. So this money, they go effectively, this is money we pay for the service to use the money that we received. And this value and this money goes to reduce our debt. So the higher the fraction of the interest payment on the annuity, the worse. So out of this amount, we pay 44% just for the opportunity to use money. The smaller it is, the better. Make sense to you?
Yes, thanks.
Well, this is the real thing. So when you go to the bank, you have some conditions. You can write the conditions you receive in this table, and you should have the same annuity payments if you use the right results. So you can use it in your practice if you need to borrow money. But also for sure for some corporate estimation, then the firm borrows money, of course, the technique remains the same. Okay, let me stop this and let's move back to the slides. Here I put those slides. This is the same materials that we just discussed presented on the slide. Future value of annuity. Alternative settings, but related to the one we discussed, is then instead of borrowing money, we can invest money. So we put the same amount of money every month, and on each of this amount we have interest rate receiving. This is the opposite settings, but the principle is the same. And this is how we approach it. Future value of annuity would be this cash flow monthly payment multiplied on the present value of annuity factor. And we also should apply compounding here to multiply at 1 plus r in the power of t, where t stands for the number of periods. This is the same formula, just we substitute present value of annuity factor here with its name, and this formula can be converted, but no, this is the same. It's just result of mathematical transformation of this formula. Here we have another setting that this formula answers to the question, how much money would I have if I would invest regularly C at the interest rate of R for the T number of periods. This is the example. What is the future value of 220,000 paid at the end of each of the year for 5 years if your investment returned 8% per year? If we would just multiply it on 5, we would have 100,000. But 17,342 is the extra interest that we earned on this money. In Excel spreadsheet that we would share, there is a same table that we just discussed. Now I would, in order to save the time, present it here. The principle is the same. We invest some amount of money and we earn some money on that. So this 102.63 is result of multiplication of beginning of the month's balance on the monthly interest rate. And at the end, we would have this amount of money. This is the same amount we would receive if we apply the formula. In Excel, please, as your homework before the seminars, please work with the spreadsheet, understand how it is organized to see how we estimate the present value of annuity and future value of annuity. This is another modification of this formula with annuity. In order to compare the first settings and the second settings of the settings, then we borrow money, and the settings, then we invest money. This is so this will be the total loan amount over payment. So the total value at this column, the total value here, plus the total value here. So this was the first one was this one, the second one was this one, plus the present value. In our case, it was 800,000, and we would have the same result. In Excel spreadsheet, I did this estimation. Please take a look and make sure that they are really equal. The takeaway from here is that it's better to invest rather than to borrow money, because when you invest, your wealth accumulation exceeds the amount that you might lose if you borrow the money under the alternative settings. When we talked about annuities, we mentioned that annuity or perpetuity assume that the first payment is made at the end of the period. But what we use, then the first payment is made immediately, so at the beginning of the period. Then such type of cash flow is called annuity due. It can be also perpetuity due. It doesn't matter. The only adjustment that we need here is to use one step in compounding, so 1 plus R. And this is called annuity due. So again, annuity due, the first payment is immediately. Annuity, the first payment is at the end of the first period. This is a big difference. Do not confuse. There are many of your colleagues failed here and had some grade reduction. So please keep this in mind. This is the example for the annuity due. You annually invest some amount of money at the 10% of interest rates, how much you would have after 50 years, assuming that you made the first investment immediately. You see, if we make the first investment immediately, this is the part that appears here, because we need to have additional step of compounding, because as we receive money one period earlier, we would have more money at the end. Does it make sense to you or not?
I think yes.
Yes. This is these things. They are very logical. Just if you do not understand it at the moment, please, before the seminars, take time to replicate the estimations that we use here. Also use the spreadsheet that we share, and this would make sense to you perfectly, because there is just the pure logic with the simple math instruments. Another, I think it is, yes, this is the final type of cash flow that I want to introduce for you today. This is a growing perpetuity. This is close to the perpetuity. The only difference would be that every period, the amount that is paid is increased at the same growth rate. This is a concept that is very important for us when we'll talk about the corporations, because corporations supposed to grow. They are not just infinite, they should grow infinitely. And that is why this is very useful cash flow. Again, the formula is very simple one. We just have, the only change that we have is that we add minus growth rate. You see, if the growth rate exceeds the discount rate, then it will not work. But no, then we have infinitely high present value of such perpetuity, but no, in real settings it cannot be the case. Discount rate is getting smaller. If we work with the younger firms that might at the first steps grow very fast, then in our economic model we will have separate parts. We have the initial part, initial period, then the growth is very high, but eventually we assume that the growth will get stable. So at the stage where we move into infinite estimation, when we apply perpetuity, the growth rate should be not too high, because nothing can grow very fast forever, because it will there are natural limitations for that. This is the formula. Also in your books we have the logic would be very exactly the same. Out of this perpetuity, growing perpetuity formula, we can also derive the growing annuity. If you want to be shining student in the course, you can take a look how we derive that, but I believe we will not include it into the basic part. Just keep in mind that there is a formula for the settings. Then we have limited number of periods, and cash flows grow every period at the same rate, and this is annuity, and we can have a separate formula for growing annuity that would be derived from the growing perpetuity formula. This is the settings that we can use, and this is the same example we had a couple of slides ago. 1 billion paid forever, 10% discount rate, but additionally we have 4% growth rate, and instead of 10 billion we have 16.6 in period billion. So this 6.666 difference is due to the growth. That is why growth is very important, particularly when we talk about infinite cash flows or longer term cash flows. This is it for today. Good timing. Questions, comments, clarifications, suggestions?